Okay, let us start. लास्ट टाइम हमने लाइन इंटीग्रल की बात की थी. लाइन लाइन इंटीग्रल क्या होता है? लाइन इंटीग्रल we have some vector field V, can be any vector. We dot it with the infinitesimal displacement vector. Then we integrate this dot product over some initial point to final point, where V is a vector field. dl is infinitesimal displacement vector. And integral for example, if this is space x, y, and z, and in this space there exists this vector field, and we move along some path, some path A to B. This vector field will have different direction and magnitude at different places. For example, we take this point here. This is my dl. Let this vector field be this way. So at every piece of this path, we have to find a displacement vector pointing from initial point to final point and dot it with the initial point vector field of the infinitesimal displacement vector. So this way we calculate line integral. We can give example. Example is work done by a variable force. So we have some force which acts on a particle, and ds is the infinitesimal displacement vector over which it is constant. Then we integrate it from A to B along some path to calculate the work done by this force along the path considered. So this is the example. Similarly, we have surface integral. Surface integral. So in case of surface integral, we have some vector field. So I draw it this way. If this is my space, x, y, and z, and in that space, I have some surface. I divide this surface into infinite small parts, dA, and represent each dA by a vector perpendicular to the surface. Then dot it with the value of the vector field there. I dot it with the V. V stands for my vector field. Then I integrate it over the surface. Right, S, that means I integrate it over the surface which we are constrained. We get the surface integral of the vector field. And if the surface is a closed surface is a closed surface, then we write a small circle on the integral, which means that we are integrating the surface integral for a closed surface. And in this case, in this case, that means in the case of closed surfaces, it is a convention. It is a convention that dA is taken as outward normal, right? So this was the surface integral. Now I will give you a question. Question is, calculate the line integral of the function, line integral of the function v equal y square I cap plus 2x into y plus 1 j cap. Y square I cap plus 2x times y plus 1 j cap. From the point, from the point a equal to 110 to the point b, to the point b equal to 220. Along the path, along the paths 1 and 2, along the paths 1 and 2 in figure 1. Let this be question number 1. So here, so I will draw the figure. My figure is like this. This is x, this is y, this is 1, this is 2, on this side, this is 1, this is 2, point A, I have point B, my path 1 goes like this. This is my path 1, and my path 2, I will use a different color. My path 2, goes like this. This is my path 2. In path 1, I go along the x-axis from point 1, 1, first 2, 1, then from 2, 1 to 2, 2. In path 2, I directly go along this way from point 1, 1 to point 2, 2, right? And there is another portion of the question, right here. What is the value of the closed integral v dot dl for the loop for the loop for the loop that goes from A to B, that goes from that goes from A to B along 1 and returns to A along 2. I will give you the answers. This is your homework. For path 1, for path 1, for path 1, the answer of the line integral is 11. For path 2, it is 10. For path 2, it is 10. And value of the line integral, value of the closed integral is 1. Okay, this is all for today. Thank you.